All right, let's jump right in. If you've ever written any Java, you know the feeling when your program just crashes. It's so frustrating, right? Well, today, we're going to take those scary program-ending errors and turn them into something you can actually control. This isn't just about squashing bugs, it's about learning a core skill that really separates the pros from the rest. I mean, really think about that for a second. That moment when everything just stops. You get a freeze, maybe a huge wall of text that makes no sense. It's such a sudden, jarring end to your program. And that feeling, that's exactly what we're going to learn how to prevent today.
So, here's the game plan. First, we'll look at how perfectly good code can suddenly break. Then, we'll dig into Java's built-in safety net for these moments. After that, we'll get our hands on the 5 essential keywords you need in your toolkit. We'll put them to work in a real example. And finally, we'll talk about why knowing this stuff really levels up your coding game.
Okay, first things first, we have to understand the problem before we can solve it, right? So, let's do a little anatomy of a program crash. This is where we see some code that looks totally fine on the surface, until it's not.
Take a look at this. It's a super simple piece of code. I mean, what could go wrong? But hidden right there in plain sight is a logical impossibility. We're trying to divide by 0. It's basically a ticking time bomb just waiting to go off and bring everything to a grinding halt. And boom! The program doesn't just give you a weird answer, it completely dies. It spits out this cryptic message that developers call a stack trace. For a user, it's just nonsense. And for a new coder, it's pretty intimidating. It's basically the program's last will and testament, and it offers no way forward. But what if I told you that Java is smarter than that? It doesn't just throw up its hands and crash, it actually gives you this incredible, elegant solution, a built-in safety net designed to catch these exact kinds of problems. This is the moment where we stop being victims of errors and start taking control. And here's the absolute key to understanding this. An exception isn't just some random error message. It's an object. Think about that for a sec. An object holds information, it has a structure, and because it's an object, we can actually grab it, look at it, and use it to make smart decisions in our code. Java even organizes all of this for us in a neat class hierarchy. See, at the very top, you've got throwable, and that splits into 2 big paths. Now, we're going to pretty much ignore the error path for now. Those are like catastrophic system failures you can't really do anything about. Our focus is on that other path, exception. These are the errors our code can and should be ready to handle.
So, how do we handle them? Well, to work with these exception objects, Java gives us 5 incredibly powerful keywords. You can think of them as your official error handling toolkit or, magic spells that let you control what happens when things go sideways.
And here they are. First, you've got try. That's you telling Java, hey, watch this next bit of code. It might get a little risky. Then comes catch. This is your backup plan. It says, okay, if that specific error happens, do this instead. The others, throw, throws, and finally, are for more advanced stuff. But for now, we're going to focus on that powerhouse duo, try and catch. All right, enough theory. Let's get our hands dirty. It is time to take that code that crashed on us and, well, tame it. We're going to use the tools we just learned to turn what was a fatal error into just a little bump in the road. And just to be clear why we're doing this, it's for 2 huge reasons. First, it gives you a chance to actually fix the problem on the fly, maybe by using a default value or something. And second, and this is huge, it stops the program from crashing. That means a way better, way more stable experience for whoever is using your application. Okay, let's look at the code. We wrap the risky part, the division, inside a try block. That's our danger zone. Right after it, we have our catch block. This is our safety net, and it's specifically waiting for an arithmetic exception. If that exception happens, the code inside the try block stops immediately and control jumps straight to our catch block. And here is the result. It's kind of beautiful, right? Instead of that scary crash message, we get our clean, friendly output, division by 0. But look closer. The program kept going. It printed after catch statement. The error was caught, handled, and the program just continued on its merry way. That is what control looks like. I mean, this slide really says it all. Look at the difference. On the left, you have chaos. The program crashes, you get that confusing stack trace. On the right, you have order. The program continues, and you get a clear, user-friendly message. It's the same problem, but the outcome is completely different, all thanks to one simple try-catch block. So let's bring it all home. What we've been talking about isn't just some clever Java trick.
It's a fundamental change in how you approach writing software. It's all about building applications that are robust, resilient, and don't just fall over at the first sign of trouble.
And remember this, the real goal of a great catch block isn't just to print an error. The best error handlers try to fix the situation. Maybe you set a variable to a default value and just move on. The idea is to handle that little hiccup so smoothly that the rest of the program doesn't even know anything went wrong. And here's a little pro tip for you. Remember that exception object we caught? Well, instead of printing a custom message, you can just print the object itself. It gives you a perfect one-line summary of what happened. This is awesome for logging or debugging because you get the exact details without that huge noisy stack trace from before.
So there you have it. We went from a hard, ugly crash to graceful, predictable control. We turned a total catastrophe into a manageable event. Now you have the power to anticipate and handle errors in your own code. So the only question left is, what kind of awesome, resilient applications are you going to build?